Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at ICMP messages. We'll be discussing ICMP version 4 and ICMP version 6 messages, host reachability, destination or service unreachable, time exceeded, and then finally we'll take a deep look at those ICMP version 6 messages. This episode is part of my series on Introduction to Networks for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Internet Control Message Protocol provides feedback on our network and about the devices on those networks. ICMP version 4 is for IP version 4. ICMP version 6 is for IP version 6, and it includes some additional functionality not found in ICMP version 4. There are a couple types of common messages between ICMP version 4 and ICMP version 6. Those messages are host reachability messages. Can we actually reach the host? Because from the host we're on, can it reach a destination host? Destination or service unreachable. It's going to give us a message back saying, oh, sorry, it can't reach that. And then also time exceeded. It took too long to get there. Maybe there was too much congestion on our network. ICMP version 4 messages are not required. ICMP version 4 messages are not required. IP version 4 does not require ICMP version 4 messages to work. Typically, ICMP version 4 is not allowed on a network. Network administrators consider it a security risk and they block that type of traffic. ICMP provides host reachability functionality. What that is it's the ping function. And the ping has two parts to it. One is an echo request, the other is an echo reply. First thing happens here is H1. H1 sends out an echo request. That travels through the network. And here we go through a switch, a couple of routers to another switch, all the way over to H2. H2 gets that echo request in, processes it, and then they send back an echo reply. That echo reply takes the same journey, and once again, this is the reply going, takes the same journey it took to get there through a switch, through two routers and another switch, and finally it reaches back to its destination. And so that allows us to know that, hey, that host we're trying to reach is there. And it's a two-step process. One is the echo request, needs to make it all the way there. Echo reply is from the host we're contacting, needs to make it all the way back to us. And then that's a successful ping. When that ping doesn't successfully work, we get a destination or service unreachable. We notify the source that, hey, we couldn't get to that source, we couldn't get to that, or we couldn't get to that destination, we couldn't get to that service, and we're going to let you have a message that says so. ICMP will include a code. ICMP version 4 has basically 4 codes. The network's unreachable, the host is unreachable, the protocol's unreachable, or the port's unreachable. ICMP version 6 codes, there are 5 of those codes, and they're a little bit different than the IP version 4. 0 is no router destination. We don't know how to get there. 1, communication administratively prohibited. That's like a firewall. You don't want people connecting to your firewall. 2 is beyond the scope of the source of the network. That is just, it's outside of our network. 3, we can't reach it, or we can't get to that port that you're looking to ping. They are similar, ICMP version 4 and ICMP version 6. Those codes are similar, but yet they're a little bit different. If the ping takes too long to reach its destination, you're going to get a time exceeded message. The time to live is that measurement we use. The time to live is a number, and every time it goes through a host, it decrements by 1. It goes down 1. On a lot of times it's 128. Every time it goes through a router, it goes down by 1. Go through the first router, it's down to 127, 126. And then finally, when it gets to 0, it's going to say, hey, I can't reach it. It's taking too long. And we're going to give you a time exceeded message that is going to be sent back to the host. ICMP version 6 also has their message, but it's the hop limit field. A little bit different, but it handles it pretty much the same way. Here we can see we are pinging 8888, Google's DNS server. And what's happening here is it's getting a reply back from 192.168.1.1. And if I had to guess, that's our router here. And it's saying time to live expired in transit. Now notice we sent 4 packets, we received 4 packets, and we lost 0 packets. Now some may consider that good, but the analogy I use is when you go in and apply for a job and a week later you get a letter from them, does that letter mean you got the job? No, you have to actually open it up and read that letter. Here, same thing happens. You have to go back and you have to read the message here. It said time to live expired in transit. Typically, if it's a negative message, it failed. What it's saying here is I went from my host to the default gateway. Default gateway tried to reach the destination. Destination was unreachable, and so my default gateway sent me a message back saying, hey, I tried to get there, but the time to live expired in transit. I hope you're liking this episode on ICMP Messages. If you have the time, please leave a comment and let me know what you think about ICMP Messages. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. ICMP version 6 messages. ICMP version 6 has several new and improved messages, functionalities that wasn't found in ICMP version 4. Typically, it's the Neighbor Discovery Protocol, ND or NDP. You can use both of those abbreviations to represent Network Discovery Protocol. With the Network Discovery Protocol, it happens sort of in 2 areas. Messaging between an IP version 6 router and IP version 6 device. Communication happens between that. First one is the router solicitation message. When a host turns on, it searches the network for the router, its default gateway to get off the network. It sends a router solicitation message. In response to that, a router advertisement message is sent, and that provides network information to the host. It goes from the router to the host. Also, messaging between IP version 6 devices. So the first one was router solicitation, router advertisement. That happens between a host and a router. The next type is messaging between IP version 6 devices. And so 2 PCs running IP version 6, a PC and a printer, PC and a mobile device. It's the end devices, they're communicating back and forth. First one is a neighbor solicitation message saying, okay, is there any neighbors out there? Is there a neighbor out there with a specific IP version 6 address? The other one is a neighbor advertisement. That neighbor advertisement is basically saying, hey, I'm looking for a neighbor with this IP version 6 address. Is there anybody out there? Now, ICMP version 6 Network Discovery Protocol also includes a redirect message. And what that redirect message is, it deals with the routing protocol. And basically, when a device connects to it, it's going to say, hey, I know you think this is the best way to do that, but we found a better way to get to your destination. Use that path. That's what the redirect message is. Router advertisements are sent once every 200 seconds in IP version 6. That provides addressing information for the PCs. That router sends out a message once about every 3.5 minutes that says, okay, here's some information, network information, prefix information, DNS information. It sends it out to all the devices on the network. You can provide updates this way if you have a change in DNS or something like that. That can go out that way. The router advertisement message can include addressing information. It can include the prefix. That's that network portion of the IP version 6 address. What exactly is that? In here, in our example, the network portion would be 2001 DB8ACAD:1. That would be the prefix. The prefix length is how long is that? Out of our 128-bit IP version 6 address, how long is that network portion? In today's network, it is typically a /64, but in the future, we could see that number varying anywhere from 0 to 128. It also includes DNS address information and a domain name. That information can be handed out through a router advertisement. Hosts using stateless address auto configuration or SLAC we hand out our default gateway through these router advertisements. If it's a local link address, it'll be handed out through that router advertisement. The reason the router solicitation message was sent out is there was a host on the network that needed to figure out, how do I get my IP version 6 address dynamically? And that router advertisement will have that information in it. R1 replies to the router solicitation with a router advertisement. Here in the diagram, we have PC1 over here. PC1 just came on, it just booted up. And so it sends out our router solicitation message onto the network. The router hears that and says, okay, here is the information that I'm going to send to you in this router advertisement that will allow you to get your IP version 6 address dynamically. An IP version 6 address may perform a DAD. A DAD is a duplicate address detection. Basically, it's going to send out a neighbor solicitation message with its own IP version 6 address as the targeted IP address. And so what PC1 is going to do over here, it's going to send out this neighbor solicitation message. That neighbor solicitation message is going to put its own IP address in there, its own IP version 6 address as the target. And it's going to look on the network. Does that address exist anywhere? Now, if a device replies back with that address, it's going to get it's going to go through the process to get a new dynamic address. But if nobody responds to that DAD, that duplicate address detection, the network solicitation address targeted at the address it's going to use, that means PC1 can use that IP version 6 address. Now, DAD, that duplicate address detection, is not required, although there is an RFC that recommends it be performed on any unicast address just to make sure that nobody else is using that one. In order for a device to send a message to a destination host, we don't use IP addresses. Not IP version 4, not IP version 6. It uses a MAC address to go from device to device, from network interface to network interface on our network. And so what happens here is R1 needs to send a message to PC1. R1 sends a neighbor solicitation message to the address, the IP version 6 address it knows. The IP version 6 address at the host here is going to respond with a network advertisement. That network advertisement includes the MAC address, and that's sent back to the router. The router then knows the MAC address to properly form that layer 2 frame and send it over to the PC. This is similar to the ARP process in the IP version 4 protocol suite. It was my pleasure to provide you with this wonderful episode on ICMP Messages. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks. In the bottom right is one of my favorite videos that I picked just for you. Thank you so much for watching this episode of my series on Introduction to Networks for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.